Okay, guys, this is week 5. All right. This lesson is going to involve solving for the missing sides of a right triangle and some applications with it. Okay. So hopefully switch your calculator to degree mode. All right, and let's get started. Okay. Well, let me get a comfortable seat here. I think I'm sitting very comfortably. Give me just a second. Okay. Here we go. All right, so given the right triangle shown below, set up a trigonometric ratio involving the angle A and then use it to find the measure of A to the nearest degree. Okay, so the angle we're trying to find is this guy right here. Okay, and so in order to do that, we're going to use these two side lengths right here. Okay, now we could also find this length right here of this side if we wanted to using Pythagoreans, but that's not what the question's asking. It's asking us to find that angle measure. All right, so here's theta. All right, here's SOHCAHTOA. Okay, and so what we're looking for is, well, let me label my sides here. So hypotenuse, opposite, adjacent. Okay, and so we're looking to see which trigonometric ratio involves our hypotenuse and our adjacent side. And that would be cosine. So the cosine of theta is equal to 17 over 22. Now in order to solve this, okay, we're going to have to use that thing from that last lesson a few back, that arc cosine, okay, or the inverse of cosine. Okay, and what that does is it gets rid of this on the left, and we're left with just theta. And then we have to find the calculator. Okay, so we're going to go second cosine. Make sure it's in degree mode. 17 divided by 22. And you get theta is equal to 39.4, and let's see, what does it tell us to round to the nearest degree? So 39 degrees. Okay, so that's what these trigonometric ratios are used for. They're used as a way to find angle measures or the lengths of sides using these ratios. Okay, so pretty neat stuff. So if we have two sides of any right triangle, then either of the acute angles can be found using the inverse trigonometric ratios. But even more importantly, if we have the measure of an acute angle in just one of the sides, then we can find any of the other sides as well, and also find the other angles and stuff. So in exercise 2 here, we're just quickly going through how to solve multi-step problems here. Okay, so if I wanted to solve for x here, all right, I would multiply both sides by 6, cancel on the left, x is equal to 30, right? 30 divided by 6 is 5. Okay, this one should be 6, right? 18 divided by 6 equals 3, but we're going to make sure we solve it correctly. So it's going to be 3x is equal to 18 divided by 3, x is equal to 6. Okay, we're still solving for x. We're going to multiply both sides by a, so ab is equal to x. And then down here, multiply both sides by x first, so we get bx is equal to a, divide by b, and you get x is equal to a over b. Okay, and so the point of doing this is just to get you comfortable back with how it is you solve for particular variables in the problem. So if you can solve these, then finding a missing side of a right triangle is fairly easy using trigonometry. Exercise 3. So it says in the following diagram, one of the acute angles is given and one of the legs. So in the last problem, they gave us both. They gave us at least two lengths of the sides. This time they're only giving us one and the angle. So it says solve for each of the other sides of the right triangle. Round your answers to the nearest tenth. Okay, so let's solve for MP. All right, so I'm going to label this my opposite side. This side is directly across from my right angle, so this is our hypotenuse, and this is our adjacent. So I'm going to write SOHCAHTOA up here. Okay, and so which side involves our adjacent side and our opposite side? We'll Well, that's going to be tan. So the tan of 36, well, I don't want the degrees there, 36 is equal to an opposite, which is going to be x, over adjacent, which is 28. Multiply both sides by 28. And so x is equal to the tan of 36 times 28. So tan, not the inverse tan, just tan of 36 times 28. And you get 20. It says round it to the nearest tenth, so I'm going to say 20.3. Right, so that's the length of our opposite side. If you want to find the length of PN, all right, well, we're going to have to use which side involves the adjacent and the hypotenuse. Well, that's our cosine. So cosine of 36 is equal to 28 over x, because we don't know what our hypotenuse is. So we multiply both sides by x. To get x times the cosine of 36 is equal to 28. Divide by the cosine of 36. Cosine of 36. You get x is equal to, so 28 divided by the cosine of 36 now, and you get 34. It says round it to the nearest tenth, so 34.6. All right. And we just used our trigonometric ratios to find the lengths of all the sides of this triangle. Okay, and if we wanted to, we could also find that angle as well. You're going to have to use trig functions for this, because you got to remember all triangle sums add up to 180. And so in which case we would just add up 90 and 36, subtract it from 180, and, well, that'd be 180 minus 126. And so that last angle is going to be 54 degrees. But that's not what it's asking. Okay, so that's exercise 3. Exercise 4 kind of gives you some keys to solving for the missing side of a right triangle. So it says know one side in one acute angle. Set up a proper trig proportion and solve the proportion for the missing side. So using the diagram below in trigonometry, find the length of BC to the nearest tenth. Okay, so BC is this one right here. So that's our adjacent side. This is our hypotenuse, and this is our opposite side. Okay, so let's rock and roll. So which, well, SOHCAHTOA. Okay, so which side involves our adjacent and our hypotenuse? Well, that's cosine again. So the cosine of 24, okay, is equal to x over 18. Multiply both sides by 18. And so x is equal to the cosine 24 times 18. And you get 16.4, so it's round to the nearest tenth. Okay, and find the length of BC. There you have it. All right, exercise 5 is interesting here, okay? It involves some properties of an isosceles triangle. All right, so an isosceles triangle has a base of 26 inches and base angles that measure 64 degrees. Determine the height of the isosceles triangle and the length of its legs to the nearest tenth. Okay, so let me draw this isosceles triangle in here. Well, maybe I can move this in here a little bit. There we go. Close enough. Maybe a little bit more. There we go. All right, so there's our isosceles triangle, right, which means that these two sides are the same, which means these two angles are the same. And what's neat about an isosceles triangle is if you bisect this angle right here, okay, it should take you directly down, and actually will bisect our opposite side as well. Okay, so this is only for isosceles triangles, well, and for equilaterals as well. You know, you can take an equilateral triangle. Let me see if I can draw one here. Whoops. Right, same process. If these are all equal sides here, all right, it'd be the same thing. Whoops. All right, but that's only for equilateral and isosceles. So it's got a special property here. So if we bisected that angle, it would also take you down and bisect this side on this opposite side as well. All right, so it says the height of the isosceles triangle to the nearest tenth. All right, so And the height is always measured too, from the base all the way up to that top angle there, and it has to be a perpendicular line here. As you can see, that's why we have that right angle measure in there. So, in order to find that height, what we have here is actually two congruent triangles. Okay, so I'm just going to take this triangle here and break it off to the side here. Whoops. There we go. And there we go. Okay, so there's our right angle. This is 64 degrees. It says our base is 26. So if we were to split that up in half, this would be 13. All right, and so in order to find our height, we want to find this side right here. So this is adjacent. This is opposite. So TOA. All right, it says, or we're looking for which trigonometric ratio involves our opposite and adjacent side. That's tan. So the tan of 64 is equal to x over 13. Multiply both sides by 13. You get x is equal to the tan of 64 times 13. Round it to the nearest tenth, so 26.7. That is our height. Now the length of its legs to the nearest tenth. So what it wants us to find now is the length of this side here. Okay? And so the length of its legs to the nearest tenth, all right, we're going to use which trigonometric ratio that involves adjacent and hypotenuse. Well, that's cosine. So the cosine 64 is equal to 13 divided by x. Multiply both sides by x. So x is equal to 13 divided by the cosine of 64. And so the cosine of 64, 13 divided by the cosine of 64. And you get 29.7, rounded to the nearest tenth. And that is how you find the length, or the length of that leg right there. Okay? All right. So exercise 6. So in exercise 6, it says in the right triangle PQR, Q is the right angle, M is equal to, or the measure of angle R is equal to 48, and one of the length of PQ, one of its sides, okay, is 11. Which of the following expressions correctly calculates the length of PR? So let's draw our right triangle here. Okay, there's our right triangle. This one's Q. So we're just going to start up here. PQR. Okay, R is 48 degrees. This is PQ is 11. So it wants to know which of the following expressions correctly calculates the length of PR. Okay, so this is our opposite side. This is our hypotenuse. And this is our adjacent. So it wants us to find our hypotenuse. Okay, so SOHCAHTOA. All right, and which side involves our hypotenuse and our opposite side? Well, that is sine. So the sine of 48 degrees, why do I keep putting degrees there? Just 48 is equal to, and so it's opposite, which is 11, over our hypotenuse, which we don't know, which is just x. Multiply both sides by x. Let's cancel here, so you get x is equal to 11 divided by the sine of 48. So we would divide both sides by, sine of 48. Okay, divide both sides by that. So you get x is equal to 11 divided by the sine of 48. So 11 divided by the sine of 48. And you get, well, actually that's not even what it's asking. I'm sorry, we don't even have to do that. Which expression? Perfect. We're done. Right there. Right? That's how we find it. Okay. Let's keep going here. So, trigonometry applications. Okay, so it says right at the beginning, math can many times seem very disconnected with everyday life. What's nice about trigonometry is it is used quite quite a lot in the real world when it comes to, architecture and, building things and construction and stuff like that. So it does play a little bit of part. Now, I don't think people are remembering these trigonometric ratios. I don't think construction workers are walking around, memorizing SOHCAHTOA. But those that are familiar with these ratios understand that that's where a lot of this stuff comes from when you're building stuff. So anyway, a ladder will be unstable if the angle it makes with the ground is greater than 60 degrees. So if a 12-foot ladder is used to reach a window 10 feet above the ground, will it be unstable? Justify your answer. Okay? So what we're looking for is we need to find what that angle measure is. And if it's greater than 60, that means our ladder will be too unstable. All right, so we're just trying to make sure that our ladder is safe to put up on the wall like this. Now again, like I said, people aren't walking around, well, if I put this ladder like this, my degree measure, okay? It's a goofy problem, but it's cool that it can be solved using trigonometric ratios. All right, and so I'm going to label my side. So this is my opposite side, my adjacent side. Here's our hypotenuse. Okay, and so which side or which trigonometric ratio involves our opposite and our hypotenuse? That's sine. So we don't know what our angle measure is yet though, so the sine of theta is equal to opposite 10 over 12 hypotenuse. Okay, and so we're going to take the inverse of sine, or the arc sine, and this allows us to cancel that stuff on the left, and then it gives us our angle measure. So the sine, inverse sine, 10 divided by 12, so second sine, you get 10 divided by 12, and so you get 56.4. Now that's not what the question's asking. The question's asking, okay, if it's greater than 60 degrees, it will become unstable. So because it's less than 60 degrees, we would say, will it be unstable? We'll say no, because our angle measure is less than 60 degrees. Okay? All right. Let's keep going here. So number 2 says to determine the height of a tree, loggers will measure the angle of elevation at the top of the tree from a set distance from its base. If the logger's eyes are 5 feet 3 inches above the ground and the angle of elevation to the top of the tree is 38 and standing 25 from the base, 25 feet from the base, determine the height of the tree, to the nearest inch. Okay, so we want to find this height first, and then after we find that height, we're going to add the height of our human to that. Okay, and it says determine the height to the nearest inch. Okay, and that part will play in a little bit later. So we want to find what that height is so far from the guy standing there. All right, so here's our triangle. This is our adjacent side. Here's our hypotenuse. So we want to find what our opposite side is. So SOHCAHTOA. All right, and which trigonometric ratio involves opposite and adjacent? Well, that's tan. So the tan of 38 is equal to x over 25, because we don't know what our opposite side is. So you multiply both sides by 25, and you get x is equal to, so I'm going to go tan of 38 times 25, and you get 19.53. Right? I'm just going to round that up to 19.5. Now I'll explain why. Okay? So when we're talking about feet here, right? This is this is a measurement of feet, 19.5 feet. So what that really means is it's actually 19 feet 6 inches, right? Because half of a foot is 6 inches. So we're going to take that 19 feet 6 inch and we're going to add 5 feet 3 inch to it. And by doing so, we get 24 feet 9 inches. And right there is rounded to the nearest inch. Okay, so that is exercise 2. Exercise 3, an isosceles triangle has legs of length of 14 and a base of 10. So let me draw my isosceles triangle. Okay, so it has legs of length 14. So isosceles triangle, you've got to remember these things are both equal, and a base of 10. Alright, so we're going back to that one problem where you can kind of split this triangle in half here, and what happens is we actually end up getting two congruent triangles. Alright, and this only works for isosceles. Remember, it bisects this angle, so these two angle measures are the same. It bisects this length on the opposite side here, which means these two lengths are the same. Okay, so what is the measure of the vertex to the nearest degree? So what we're trying to find is that entire angle here. But in order to do so, we're going to have to find the angle of one of the smaller triangles first. Okay, so 5, 14, there's our right angle, and so we're trying to find theta here. Okay, so SOHCAHTOA. Okay, this is our opposite. This is always our hypotenuse. Okay, this is our adjacent. Alright, so it says we're looking for which trigonometric ratio involves opposite and hypotenuse. Well, that's sine. So we're going to sine of theta is equal to 5 divided by 14. I'm going to take the inverse sine of both sides. So this cancels on the left. So theta is equal to the inverse sine of 5 over 14. So second sine, 5 divided by 14, and you get theta is equal to 20.9. Alright, now I'm not rounding here yet, so I'm going to go 20.92 even. Okay, so that is the angle measure for one of the triangles. So you got to remember, with our isosceles, okay, when we make that height, if you will, all right, because that's what that line down the middle really is. It's our height of our triangle. Okay, it splits not only that angle, but these two sides down here. So which means we're going to have to take that 20.92 and multiply it by 2. And so you get 41.84, and it says rounded to the nearest degree, 42 degrees. All right, example 4. A lighthouse in Cape Hatteras, North Carolina, never been, is 200 feet above sea level, okay, which means this length right here is 200 feet. You write that in there. 200 feet. Okay. It spots a boat that is at an angle of depression from 28 degrees. So what it's saying is, like, if you were to standing up here and you're looking down, okay, you're looking down at a 28 degree depression. Okay. So that being said, I'm going to create my right triangle here. Okay. So this is 200 feet over here, which means this over here is also 200 feet. Okay, so what is the horizontal distance to the base of the lighthouse? So what we're trying to find is this length right there. Okay, so I'm going to draw my triangle here. Okay, so this is going to be, oh, I got it all backwards here. Let me draw it like we have in the picture. Okay, so this is 200, this is 28, and we're trying to find this. So this is our adjacent side, this is our opposite side, and this is our hypotenuse. So SOHCAHTOA, right, which trigonometric ratio involves opposite and adjacent? Well, that's tan. So the tan, 28, is equal to 200 divided by x. Multiply both sides by x. You get x is equal to 200 divided by the tan of 28. And then you do 200 divided by the tan of 28. You get 376.14, and it says round to the nearest foot, so 376 feet. Alright, and that is how you find the answer for example 4. Alright, last one here, guys. Okay, so a blimp hovers above the ground at a height of 1,150 feet. Observer at point A sees the blimp at an angle of elevation of 24 degrees, while an observer at point B sees the blimp at an angle of elevation of 38 degrees. What is the distance to the nearest foot that separates the two observers? So we are trying to find that length right there. Okay, so in order to do so, we're going to have to split up a couple triangles here. That's a bad one. So, we got this one right here. And we got this one right here. Okay, so this one's 24 feet. It's both the same. Whoops. Alright. You write SOHCAHTOA up here. SOHCAHTOA. Okay. So in both cases, we're trying to find the adjacent side. Okay? So, let's talk about this first one here. So, we're looking at which one involves opposite. Whoops, I wrote height twice. Way-oh. Adjacent. Okay? So, this first one here, we got to look and see, well, which one involves opposite and adjacent. Okay, so both methods are going to use tan. So the tan 24, so it's going to be 1150 over x, and then down here this is going to be the tan 38, it's equal to 1150 divided by x. Both cases are going to multiply both sides by x, and then divide by the tan value there. So down here you're going to get x is equal to 1150 divided by the tan of 38 degrees. You're going to get x is equal to 1150 divided by the tan of 24 degrees. So in the first one, x is equal to 2582.94. And down here, we're going to get x is equal to 1150 divided by the tan of 38, and you get 1471.93. I'm going to take those two values and I'm going to add these up, okay, because what we just found is this value right here and this value right here, so we add those two numbers together. 2582.94229. Try to get the most accurate answer, so when I add this number and this number together, you get 4054.87. It says to the nearest foot, so 4055 feet. And that is your answer. Okie doke. Alright, now the rest, there should be some homework down here. Okay, it's for some reason the note on this part, but there's going to be homework down here. So try the homework section. Okay, and that will be your assignment for this particular one. Okay, so there'll be some homework down there. It's not, for some reason it didn't load on this one, but just make sure to try the homework section after this part here. It should be, I think, 7 or 8 questions. Okay, alrighty guys, good luck.